All right, ladies and gentlemen, today we are going to look at solving equations with squares of binomials. Before we can do that, though, there's going to be a little pattern recognition involved here just to kind of understand how order of operations and things like that work under the square root. So what we're going to try to do is just simplify all of these expressions, okay? So the only kind of hint I can give you here is you have to do what's under the square root first. And if there's a negative in parentheses, just like there is in letters B, C, and D there, you do have to square the negative, okay? So like, let's just kind of do number or letter B together. What this would look like is you would first do negative 7 squared, because that's under the root, and that would turn into 49. And then your answer to the square root of 49 would be 7. Okay, so what I want you to do is really quickly just try all of these, fill in the answers all the way A through E. Okay, I'm assuming you've done that already, and let's kind of take a look at what our answers are there. And I'm going to zoom out just a little bit so we can hopefully kind of catch a pattern here. So we already talked about B. B, you should have gotten 7. A, you should have gotten 7. C, you should have gotten 5. D, you should have gotten 8. And E, you should have gotten 8. Okay? So what was the pattern in our answers? Basically, what I'm really asking by what is the pattern in our answers is if I were to give you the square root of something squared, so like that's kind of what I'm implying down here by the x. If I were to put any number in for x, how would you describe to someone what your answer is? I'm hoping what you said is it would always be the positive version of that number, right? So A and B were both 7, even though we started with 7 in one and negative 7 in the other, and D and E were both 8, even though we started with negative 8 in one and positive 8 in the other. This relates right back to absolute values, right? Like the pattern is that we always get the positive, okay? And our answer here would be the absolute value of x. Okay, that's what it would be. It would be the absolute value of x because we always get the positive version, and absolute values turn things positive. So what does that mean in terms of when we're solving equations? Here's what I can kind of tell you that means. If I had an equation, I'm going to write an easier one off to the side, something like x squared equals 36. Okay, what that means is this. When I square root both sides, the issue I have is this. If x started off as positive 6, that would work, right? Because 6 times 6 is 36. But negative 6 would also work, okay? So typically what I'd write here is either x equals 6 and x equals negative 6, or I could also write x equals plus or minus 6. Okay, those are two different ways of expressing that answer. Now, what does that mean in terms of solving when we have a little bit more going on under the square root? Here's what it means. It means that you have to take into account the fact that, yes, the square root of 25 is 5, but you have to also understand that if you square negative 5, you also get 25. So what you're going to want to do here is this. The square root and the squared cancel out. And you just get x minus 3, but that x minus 3 could be equal to 5, because that's what the square root of 25 is. But it could also be equal to negative 5, because that's if you square negative 5, you will also get 25. Okay, you're basically going to always be solving two little equations here, very similar to what we do with absolute values, except you need to take the square root first. So here you get x equals 8. And here you would get x equals negative 2. Okay, so kind of our list of steps is you're taking the square root of both sides to cancel out the squared, and then you're setting up two equations, one equal to the positive version of the number and one equal to the negative version of the number. Okay, why don't you try, you know what, let's look at one more. Let's look at C, okay? I'm going to skip B, and I'll let you guys tackle that one in a minute. Let's look at C really quick, and then I'm going to have you guys try B and D. So we take the square root of both sides, and those cancel, and we get 2x minus 3. But again, that 2x minus 3 could equal 3, or that 2x minus 3 could equal negative 3. And both of those things would work, because if you square 3 or you square negative 3, you get 9. Okay? Now you're just solving both equations independently of each other. Okay, so we get 2x equals 6, and then we divide by 2, we get x equals 3. And same thing over here, we're going to add 3 to both sides, and we get 0. We get 2x equals 0. This is not a no solution. I do get that sometimes. This is just 0 divided by 2, which is 0. Looks like we get x equals 3 or x equals 0. Those were two pretty good examples. Why don't you guys try B and D, and then come back to check your answers. Okay, so for B, again, we are taking the square root of both sides, and we're going to set x plus 3 after the cancel equal to both 7 and negative 7. And we're going to get x equals 4 when we subtract 3 from both sides, and we're going to get x equals negative 10 when we subtract 3 from both sides. So you should get 4 and negative 10 for that one. And then for D, same thing. I'm going to take the square root of both sides. You get 3 plus x equals 9, and 3 plus x equals negative 9. Subtract 3 from both sides, and you get 6 and negative 12. Okay, again, so that quick summary is you're square rooting both sides, and then after you take the square root of the number side, you've got to make sure to set the expression that's left. So like in this last one, it was 3 plus x. You're setting 3 plus x equal to 9 and equal to negative 9. That's it for this one.